All right, so let's work an example here. We're just going to tackle this piece by piece as we like to do. So we're going to graph this ellipse, and while we're at it, we'll summarize all of the interesting information we can about it. So what do we know? We know that we've got the equation, so we need to start there. First things first, it would be good to remind ourselves that the general equation of an ellipse is x minus h, the quantity squared over a squared, where a is the distance to the vertex in the horizontal direction from the center, plus y minus k, quantity squared, all over b squared, where b is the distance in the vertical direction from the center to the vertical vertices, equals 1. And notably, h and k are the center coordinates of x and y, respectively. So let's start there. Let's start by rewriting and putting our equation into the correct format. So the x expression is fine. X minus 2 is good because x minus h is what we're after. We want a squared. So what squared gives you 9? 3 squared. Plus, how do you write y minus something so that it means the same thing as y plus 3? Well, y minus a negative 3 will help us out in that department. Now the next question is b squared. What squared will give us 8? So the idea here in the scratch work is going to be that the square root of 8 squared gives us 8. The square root of 8 can be simplified to be root 2 times root 2. I encourage you to take a moment just to review that, but remember, you can do that by factoring down and see that you find a pair of 2's that simplifies out of the root and then 1 left over. Okay, so first things first, you don't forget about your equals 1. Now we can identify our h and our k value. So our ellipse here is going to be centered at h comma k, and in our case h is the x coordinate 2. Careful with your signs there. It's x minus h, so h is just 2, and it's y minus k, and so y is actually negative 3 because it's y minus a negative 3. Okay, the next thing we could think of is we could say, all right, which direction is this ellipse longer in? Does this have its major axis in the horizontal direction or its major axis in the vertical direction? We can tell that by looking at the a and the b values, or just the original equation. Whichever one has the bigger number being divided below it, x in this case, is going to be longer in the x direction. So we have this 3 being bigger than 2 root 2, which is a little hard to see. In fact, we're going to later, we'll do it now. A is equal to 3, and we just took the time to figure out that b is equal to 2 root 2. Oftentimes I like to write both the exact answer and the decimal approximation, because when it comes to graphing things, I know how to deal with 2.8 a little bit better than I do 2 root 2. It also helps me to see that 3 is bigger than 2 root 2. And please forgive me, I've made a fairly big oversight here. Underneath the y expression, it needs to be that expression squared because it's b squared. So since 3 is bigger than 2 root 2, or 9 is bigger than 8, any way you slice it, it's longer in the x direction. So our ellipse looks something like this. Has a center and some foci, and these are not the x and the y axis. These are the major and the minor axis is for this ellipse, respectively. If we had the case where the y was bigger, we would know that it's longer in the y direction, and our ellipse would look something like that with the foci there and have a shorter horizontal axis. In that case, the number b would be bigger. The number underneath the y expression, the b would be bigger. And I always stick to a being, we mentioned before, a is in the x direction and b is in the y direction. I always just draw the picture if I'm going to calculate c. Hey, that brings us to a great point. One of the most important things here is we need to find this c that we mentioned at the bottom, c being the distance from the center to the foci. So to figure out c, let's give ourselves a place to write c once we figure it out, and let's draw the picture. Okay, so our ellipse looks like this. And so the picture is going to be, I'm going to have my center, and I could have drawn this with the foci on the right as well, but I chose just to draw it as if it were on the left. So that line I just drew right here is the distance from the center to the foci. That's this distance right here, or this distance, whichever way you slice it. Now what do we got here? Well, we're going to have a vertical distance. What's that vertical distance going to take us to? Well, that vertical distance is going to take us to this minor vertex. Minor vertex. Okay, so what is the distance in the vertical direction to the minor vertex? Well, that's your b distance. That's your b value. So this is 2 root 2. And I'm sticking with the exact values here. We do not know the distance from the center to the focus. So that is what I'm looking for. That's c. However, we do know something about the diagonal, and I could use red because I haven't used red yet. So, all right, so I'm going to make this distance red. What is this distance here? Well, I'm going to call it A. I'm going to tell you that it's A. And so we know that it's 3. But in words, what is it? It's always the distance from the center to the major vertex. So on our picture, this C value is actually the distance from the center to a major vertex. That distance right there is the same as that distance right there. Remember, my picture isn't drawn to scale, but that relationship will always hold. Okay, so we've got our variables in place and our variables labeled. And you can just memorize this formula, but I discourage that all the time. So this is just a right triangle. So we're going to fire up the Pythagorean theorem, but careful, we're labeling the sides differently than we traditionally do. Traditionally in the Pythagorean theorem, the C is the hypotenuse, and here A is the hypotenuse. So remember, Pythagorean theorem is leg squared, so C squared plus leg squared, B squared, leg being the sides that are adjacent to our right angle here, equals hypotenuse squared, so in this case, A squared. Since we're trying to solve for C, the first thing I like to do is solve this thing kind of abstractly for C, and then I can substitute in my A and B values. So to isolate the C expression, we're going to subtract B squared from both sides to get C squared equals A squared minus B squared, and then to truly isolate the C, we'll square root both sides, A squared minus B squared. Remember, you square root both sides, take a variable out of a root, you would have a plus or minus on the right, but since we know we're talking about a distance, we're going to call this the positive version. So now A squared and B squared, well, you can be clever and realize that A squared and B squared are the actual original numbers underneath, but I kind of encourage you to, that won't always, maybe we don't know A or B in the next example, so always just kind of work with the values that we solved for. So A squared, A is 3, so C is equal to the square root of 3 squared minus B squared, and B is 2 root 2 squared. Remembering that we came up with 2 root 2 as to give us 8 over here, we can see that this is the square root of 9 minus 8, and square root of 1 is just 1. So our C value is 1, and I'll label it on my picture as well. The picture is not to scale, because that wouldn't work out. But when we go to graph this thing, we'll be able to see that picture in real life. Now towards that end, let's graph this thing. We've got A, B, and C, all the important values we need to know about in order to, in addition to the center, in order to graph our ellipse. I keep stumbling on ellipse. I want to call it vertex for some reason. Definitely not the right word. So what we're going to do is we're going to do what it says at the bottom. We're going to take and we're going to use our C value, our A value, and our B value to find the key locations, key points on our ellipse. C will help us find the foci, distance from the center to the focus. And A will help us find the distance from, A is the distance from the center to the major vertex, so we'll be able to find those. And then B being the distance from the center to the minor vertex, so we'll be able to find those as well. Ready, steady, go. Give ourselves a fresh sheet of paper. Now, I've pre-written some stuff on this, so you don't have to sit and watch me write here. Don't worry about everything on the right. We're going to come back to that at the very end, and typically you would do this in the order that I have written. So let's just try it. Plot the major and the minor axes. How do we do that? Well, let's plot the one thing we do know. The one thing we do know, and we had written down on the prior page, are these 3 things. We know the center. So the center is a nice concrete point we could put down. So over 2, down 3, our center exists right here. Now that you've plotted your center, let's actually add that. Let's put step 0, center. Plot the center. Okay, now we're ready to plot our major and minor axes. Don't get fancy. Don't look in the right corner and see that the major axis is y equals -3. No, we know the major axis, since it's longer in the vertical or horizontal direction, is just going to be the line through the center in the horizontal direction. And the minor axis is going to be the line through the center in the vertical direction. And now if you're thinking ahead, yeah, you can see how those equations come from, but we'll talk about that later. Okay, so next step, don't worry about the focus yet. Let's plot our vertices. Okay, a is the distance, since it's underneath. Remember, it comes from a squared underneath my x term, so it's the distance from the center to the x, the center to the major vertex. So what we're going to do is we're going to start at our center. We're going to travel horizontally on that major vertex a distance of 3. Okay, so if I go 3 to the right, I'm going to go 1 to the 3 to the right. I'm going to land at 5, -3. If I go 3 to the left, I'm going to go 1, 2, 3. I'm going to land at -1, -3. And if you're peeking over there at the vertex, there's your equation. There are your points. All right, so now let's do the minor vertices in the vertical direction, which relates to your b value. Well, our b value in this case is 2√2, which is about 2.8. So not quite 3, almost 3. I'm going to start at my vertex, and I'm going to go up 3. Well, almost 3, 2.8. So we won't quite get to the x-axis. I'm going to start at the vertex and go down 3. There we go, not quite. I keep saying down 3. I mean down 2.8, not quite 3. So now if you want to, you could actually draw your ellipse here, but I think we should really first plot the foci. Here we go. So C being the distance from the center to the focus, C is equal to 1. I start at my center, and I know that since this thing is horizontal, longer in the horizontal direction, my foci are not going to be on the vertical axis, they're going to be on the horizontal axis. So I'll go 1 to the right and 1 to the left of my center. All right, so we've got our 2 foci here. We'll put F's by those. Yeah. All right, so now it's fun, and now it's fine to just go ahead and draw your ellipse. All right, that's not a half bad ellipse. Far from perfect, but it's certainly good enough. So now that I have this thing drawn, now and only now should I go back and try and figure these things out. Because I can just look at most of them. We all know that, hey, the first major vertex, yeah, that's a point on the grid, -1, -3. There we go, -1, -3. How about this one? Well, that's 5, -3. Nothing fancy there. Let's do the minor vertices now. The minor vertices, if you're looking at them, they look pretty complicated. But take it one step at a time. Minor vertex. It's definitely on the vertical axis. So, and we know the vertical axis goes through the point to -3, our center point up there on the right. And so we know this is 2. So our x coordinate is 2. All right, that's not so bad. The hard part is the y coordinate, and I've written in exact values here. So how did we get that first vertex? Well, we started at the center, and what we did was we went up 2.8, or in exact terms, went up 2√2. Where did we start in the vertical? Well, we started at the vertical at the y coordinate of -3. So we start at -3 and then go up the distance of 2√2. And that's the exact expression representing the y coordinate of your uppermost minor vertex, vocab. Similar logic means that to get the lower vertex, the lower minor vertex, we go down -2√2 distance from my starting point of -3, going down a distance of 2√2. So anytime you get funny root expressions, you can always follow this same logic. To get the rounded off version of it, you would say -3 minus 2.8, and you would say that this guy as an approximate value would be 2 comma -3 minus 2 -5.8, I think. Not quite 6. That's probably easier to see, but hopefully that gave you some intuition for if you're ever asked to find exact values. Last but not least, let's find our foci. Distance 1. Well, those fall nicely on grid points. That's definitely 1, -3, and that's definitely 3, -3. So 1, -3, and 3, -3 there. You're just identifying points. Once you have it drawn reasonably well, you're identifying points. If you can, use graph paper. It really helps. At least try to draw a reasonably accurate grid. And now the last thing to label are our horizontal and vertical lines that are the major and minor vertices respectively. Well, the horizontal line that goes through the value of y is 3. Well, I just said it, y is 3. This is y equals -3. And the vertical line through x is 2. has to be, again, you said it, the logic, x is always 2, x equals 2, and that's how you find your major and your minor vertex, or vertex of major or minor axes, respectively. So that's the end of this example. That's a good place to stop.